You're not going, you are going. How's that centering? Ooh. Yeah, moderate. Yeah. Yep. I'm on 1F. I didn't get all the way to G, but I'm midway through 1F.
Can I see your book?
Why?
I haven't looked.
Yourself.
I'm not going to copy.
No.
I'm not
Do
going
your
to
book.
I'm not going to even copy. I didn't even have time.
You should have done the work grades. I'm sorry. You get 3 free periods a week.
Have 5 left.
Whoa, the human eyes are crazy. I can still see my hands. Sorry, it occurred to me that I don't know the actual full frame of view for a human eye.
The human eyes.
Because I was looking at the camera with you, and it's like a tiny box. So like the human eye, I can, like if you do simply that, you can see the roof.
Yeah.
Sorry, this is the kind of shit that goes over my head. Yes. You can see yourself? Where's the mirror? But like, it's crazy because like, if you take your hand, close one of your eyes, put it right there, and then drag it all the way to the edge of your frame. Right there. You know, theoreticals are great.
Yeah.
Có lên được. Is that what? We need to do like 7, no? because this will be nice after this. Yeah, 7.
Now I'm wondering,
Like, I don't understand that.
who got IKE's methods book?
What?
Who got a quiz methods book?
I don't know. I guess.
Because it is.
Do you guys know who got a quiz methods book?
Here's a question. What did I just read?
You have
Everyone can
written,
read that, yeah?
you have written a generalized form for a function.
Generalized form of...
A linear.
No.
No?
Generalized form of...
No. I don't know.
Could be any function. It depends what f of x is. So I've literally written every graph that you need to be able to draw for all the methods in that.
Oh.
Okay, because it could be any function. Okay. For simplicity, let's consider if x was x squared. Cool, alright. So, presumably these colourful bits do something then take us to what anything does.
A is an amplification.
A is an amplification. Yeah, that's not the word I'm looking for though.
Oh, A dilates.
There we go. So A dilates.
In the y direction.
Dilates by how much? By just the number A.
No, it's
By a factor of A. Factor of A in the
y direction.
y direction. Cool. Okay, there's a little special thing.
A cannot be.
What happens if A is negative?
Oh,
Flip as well, right? So, okay. If A is less than 0, when you say flips, do we have a better way of saying that?
reflects
Oh,
along.
rotates, reflects.
Reflects along the x.
Reflects
About the x-axis.
about the x-axis. Cool, alright. Or in a simple version, this thing means it multiplies up and down. This thing means it flips up and down. Cool, cool. Okay. What does blue boy do? Say again, can you shoot a little louder?
That's D. It translates. Translates? Yeah.
Translates.
By a factor of B.
Not by
No.
a factor of.
By-
Factor of means multiplying. Or
By B. Is it just by B?
Yeah, just by B. By B units.
Along the x-axis.
Along the x-axis. You're not wrong, but you're not being specific. Which way?
Oh,
I've got minus B, so
in the positive direction.
right, in the positive x direction. Translates by B units in positive x direction. Beautiful. Okay. switch colours next to green. C. Translates in the y direction, yeah, by c units, right? So this thing is with c. Translates by c units in the positive y. Okay. And last colour, orange. D. What does D do? In the which direction? X direction, right? It's the opposite of this guy. Dilates, by factor of D in the X direction. So in other words, it does that. Is that all it does?
Is it, if it's negative, it
Negative, that does what?
negative, it reflects
Right, flips left, right, yeah,
about
reflects this way. If D is less than 0, reflects about
the y-axis.
the y axis. So it flips left and right. Beautiful. Okay, those are the fancy words for doing it. If you sit in the exam and you say, oh, it flips or it moves, no good. Okay, you've got to use the right language. You definitely have to be able to read the correct language because that's the language that's going to be written in. Cool. So you have dilations and translations. Dilation, stretch. Translation, move. Transformations are all of those things. So any kind of change is a transformation. Cool. Everyone's happy. Everyone's writing. Okay. Ah, I just noticed something.
Oh, is it 1 over D?
1 over D. So this is 2. We're happy to get going? Yeah.
Sketching
No,
it?
we're still writing?
I don't know what the arrow means when you've got the line for fx and gx.
I'm going from this to this.
Oh.
I'll explain what's that. We all good to go? Okay. So, I'm going to go from this function to this function. Okay. Are they the same basic kind of function?
Yep.
Yeah, what kind of function are they though? Parabolas. Yeah? Cool. Okay, fine. What does that look like?
It cuts 0, 0, and that's the same as it's turning
Yeah.
point.
Cool. Do we know what that's going to look like?
Vaguely.
Just looking at it, do you know immediately what it's going to look like? No?
Vaguely.
After about a couple seconds, can you figure out what it looks like?
Yes.
Yes? Okay. So, let's run through. What does it do?
It's a smiley face.
Okay, so I agree that this will make it go up by 16. What else you got?
It goes right by 1.
Right by 1. Yeah.
1 on 2.
Right, dilates by a factor of 4 that way. What does the 2 do?
It brings it in.
Brings it in by a factor of 2. Right, so in other words, it multiplies by a half is the other way. It's bringing it in.
You did both.
Okay, so next thing, which order does that happen in? There's a couple of different ways you could tackle it. B, D, A, C is a reasonable way to think about it. You could also think of it in other ways, not A, B, C, D. A, B, C, D is definitely going to get you in trouble, which is unfortunate. Right? The only reason I do A, B, C, D is because I usually teach you A, B, and C first, and then I put in D afterwards. Right? Because D is the one that typically people get annoyed at, and because it's the reverse. Right? Instead of making it bigger, it actually makes it smaller. Okay, so I'm going to go, so if we do the BDAC version, you're going from X and working your way out. Right, and that's fine, you can do it that way. Right, so you go across 1, now at 1, then everything comes in by a factor of 2, so I'm getting skinnier. We'll draw this for now. That's on base X squared. Then I move across by 1, things get skinnier, so something like that. You don't have to draw all of these, this is just to go step by step. Everything multiplies by 4, so 0 stays the same, this guy gets 4 times as high. Oops, that's not good. Cool. And then this thing goes up by 16, so we're way up here somewhere. Yeah, somewhere way up there. And it's super skinny. So that's at 116, and then we're done. Cool, fine. There are other ways of doing it, if you like. There's, what am I going to do this thing for? You can do dilations, then reflections, then transformations. So that would be A, D, reflections of positive and negatives of A and D, and then transformations B and C. So A, D, B, C, which hopefully sounds slightly familiar. Does that sound familiar? Not A, C, D, C. A, D, B, C. Okay, so in terms of time, like year 0, right, either side, that's one familiarity. There's one other thing where you have specifically saying AD minus BC before.
Oh, the quadratic form. No.
No, not quadratic formula. If that's in quadratic formula, you've been doing it wrong. Someone said it. Matrices, right? Inverse matrix, AD minus BC, determinant. No? No one remembers it? Oh, that's good. Okay. Well, good thing we revisit that pretty shortly. So, AD minus BC turns up there again, which is why I settled on this ABCD lettering, because then it works for either version. Whichever one you want, you can do it. So if we do it via that, we get, okay, all our dilations, great, this thing dilates, so now it's 4 times as high and half as thick, great, and then we reflect, there are no reflections, move across 1, up 16, we get the exact same spot. So you've got totally free to do either. Ultimately makes no difference. The only tricky bit with doing the BDAC, when you go B, that's now your centre of the graph. So all your dilations happen relative to that, so you have to be a little bit careful with it. but otherwise it's fine. This one will work pretty well all the time. Both of them have their strengths and weaknesses for simplicity. Yeah, cool, so that's that. Beautiful. We want to change this one now. And so now we make this one way more annoying. Ready. Oops, this should be under a root. Oh, we can do that too. There we go, that's much better. Okay, we'll do that. I got this. In theory, should we know how to do that? Yeah, why should we know how to do it? Because just like that, right? Yeah, I've started with the square root graph, I've ended with a square root graph, so I should be able to just transform my way to it. Okay? Do you want a minute to try and do that by yourselves? Yeah? Go. There's a track hidden in there, so just be careful. He's got something. Do you want another 30 seconds or 30 seconds? Looks like we could definitely use some practice because people are still drawing, and I'm hoping that this should take about 30 seconds. Okay, so once you get good at it anyway. Alright. Cool. Well, did anyone spot the trap in there?
There's
What's the trap?
technically two traps. The x isn't where it's meant to be, so it's actually +2.
Okay.
And if you divide out the 4, it gives you a half instead of 2.
So this, I'm going to want to change to
Plus a half.
plus.
Plus.
Minus.
Oh, here it is minus. Nope. Oh, wait, no, there. Why did I change it here?
Right, because now I've got A, D, B, C.
I did the classic methods then.
You don't have to do it that way. If you do it your own way, so long as you're getting good results, I'm okay with you doing it your way, but if you don't know what you're doing, maybe do that first. Alright. Basic version, what's my basic version look like?
3 graphs.
That?
Yep.
Cool. We can do this a couple different ways. We'll do it the DDAC way first. Okay. Move across by a half, so that's going up by a half. We're going to call that a half.
Oh, we're doing it the other way? Okay.
Negative and then 4. So everything squishes in and it flips over. So I get it. So everything's going to squish in, so it would be like that. So something like that. Yep. In fact, that should go up higher, faster. Let me redraw that.
I thought D flipped it on the X.
Flip the X directions. Reflects about the Y-axis. Yeah, so that's Y-axis, so it flipped left, right. Cool. Next bit, A. -3, so we're getting 3 times as big and negative. So we're going down there somewhere. And then the last bit, whole thing adds 3. Oh, sorry, adds 1 rather. So up to about, let's say, 1.
Damn, I was so close. I forgot to flip it.
A little bit average. So that
Oh, yeah.
distance is 1. Let's get a bit bigger. Let's switch that. Here's 1. Goes through about there. Ooh, there we go. Bottom of the board. Something like that. Cool. If you ended up with anything that's got a starting point in the top right, crosses on the right, crosses on the bottom, and then keeps going, it's a reasonable approximation. Cool. Is this a complete sketch? No, it's missing.
Intercepts.
Intercepts, right? So now we're going to worry about these intercepts. Cool. How are you going to get them?
Make X 0.
Right, solve for the zeros, yeah? Cool. What do we want first? Do the other one first. 0, 0, 0, 0, so we get root 2, so this is 0, -3, root 2, plus 1. And then this guy. 0 is what? -1, -1/3 squared, 1/9. No, divide by 4. Oh, jeez. -1 on 36 plus 1 plus half. Is that right? No. So 0 equals -3 root. Easier. Cool. So we get 1/3 equals root 2 minus 4x. 1/9 equals 2 minus 4x. Oh, I missed the 2 before, so minus 2 divided by 4 equals x is the minus. What do we get? 18, 17 on, -17 on 36. Definitely do with some confirmation there. Anybody else calculated it? Yeah? What'd you get? That? Actually, or? Yeah? Okay, cool. As long as I've got at least one verification. Cool. Beautiful. How confident are we that that green line is where it should be? Oh, no, we can't be confident where we should be. What about negative 1 minus, that's, oh, I'm stupid, that should be 17. Sorry, positive 17 on 36, my bad. Did I go the right way? Yeah, that's right, yeah, sorry. Yeah, positive 17 on 36, yeah. Yeah, cool. Cool, how confident are we that the green line is where it should be?
Yes.
Yes. We are, yes, confident. Okay.
Of course, yes.
Okay. How might we reassure ourselves or question it?
Run through the transformations, or
We just ran through the, okay, so we just ran through the transformations to get there originally, so doing the same thing twice, we're likely to make the same error, so that's no good as a check. We could put some random values in. Okay, what value would you like to put in?
1.
Negative 3. Okay, why negative 3 out of curiosity? Okay, so negative 3 should be pretty negative. That seems like an interesting argument. Okay, if we put negative 3 in, we get 2 minus negative 12. So we get root 14, which is already making life difficult. Then times that by negative 3 and add 1. Right, so negative 3 times root 14 plus 1, is that very negative? Yeah, it should be, right? Okay, how confident, has this changed your confidence level though? Not particularly, right? Because you got that root 14 in there and you're a little bit jittery on it.
1?
Okay, if we try to put in 1, what happens?
Oh, you get a negative root.
If you try to put in 1, what happens? Undefined, right? Does that support our graph? Yeah, because we said this thing should end at half. Yeah, okay, fine. So that seems okay. How about we put in just negative 1? Okay, so we put in negative 1, we get root 6 times negative 3, so root 3 negative 6 plus 1. That should be moderately negative, that seems okay-ish. Well, we'd really like this to be an actual nice number.
So find a number that makes it a square number.
Right, so let's say that we want this thing to be 1, because then we get 1 times negative 3 plus 1 would be negative 2. So what would make that equal 1?
Negative.
Negative 3 on 4? No. All you're doing is you just take that middle bit. We want it to equal 1. If we can't solve this, we're really in trouble in year 12 methods. Quarter, yeah? We get there? Okay. Jesus. Horrifying? Okay. So, if we put in a quarter times 4. 1. 2 minus 1. 1. Square root of 1. 1. Negative 3 times 1. Negative 3 plus 1. Negative 2. So, a quarter should go to negative 2. A quarter would be halfway in between here. Negative 2 maybe is there. So, possible. What did we say? Negative, sorry. Quarter is negative 2. Quarter is negative 2. Okay. Well, that gives us some confidence because it looks about right. How confident are you about this value? Where is negative 3 times root 2 plus 1?
On the...
Do you have any idea?
Well...
This is around negative 6?
Around negative 5.
Around negative, okay, so now you're changing numbers as well. So that doesn't inspire us with
Okay,
confidence.
so...
Okay, is this a nice number?
Not really.
No, so this is why you want to know some of your square roots roughly.
1.
Square root of 2, does anyone know roughly? 1.4, okay? 1.4 times 3. Right, negative 4.2 for that, plus 1. Negative 3.2. Is negative 3.2 below negative 2?
Yes.
Okay, so that gives us pretty good confidence that we're right. Cool. So you want to know square root of 2 at the very least. Ideally, you probably want to know square root of 3 as well. Just to like one or 3 decimal places somewhere in there. Just so you've got a rough idea of where it is. That's that. Beautiful.
I'm pretty sure.
Totally forgot what the next thing I wanted to do was.
What am I? No, not 1.75.
Yeah, 1.73.
Like this one.
Oh, okay. When we went from here to there, right, we underwent several transformations. I want you to describe in words how you got from there to there
On paper.
on paper.
Like the rotation.
Okay?
When you blend like a box.
Does anyone not know what's happening? Okay, looking at me blank. Okay. I went from this to that. Yeah? So it took this to whichever the end thing was up here. Yeah? I want to get the words that describe how to move from here to there. Cool. So you're using these words specifically, right? Because you can get these sorts of questions in that exam. They're really annoying because you have to write actual words, but they can come up, and you certainly have to be able to read them. So if you can write it, presumably you can read it. You know what you're doing there? So, what did you do to this to get to there? Okay, so I want you to write that, but use the proper words. Right? Dilate, translate. Yeah? Cool? You got something, guys? Yeah? Okay. Another 30 seconds or less, or don't know too many people got their heads in the books, okay? No, that's fine. No. Here we go. So, does anyone want to volunteer? No?
Spinny time. Random number generator windows. I could. I'd rather see someone suffer. Specifically you. Bella's okay. No, I want to see.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 18. Yep.
No. I answered my own question.
Okay. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18.
And 11.
Did everyone get their number? No, you weren't looking. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 6. 1, 2, 3, 4, 5, 6. You ready? What's the first thing you're going to do? A, okay. What happens? What was a full sentence? What did you write? Dilates. By 4. In the wide room. Oh yeah, no, that's one. Okay, that's one thing. 4. 1, 2, 3, 4. It's like a blue story. Oh, that's totally good. Jeez.
I'm embarrassed. I don't ask questions.
Yeah, I see.
Okay. Yep. Next one. 2. Thomas, what else is left?
He's so nice, he's colour coded. He's colour coded. He's colour coded.
Okay.
I don't know what's what.
I want the worded version. Okay.
I should have put my
Thomas is reading
Yes.
someone else's.
yeah.
Last one. 18. Is that? Yeah. What's the only missing bit?
No.
I can't read the stuff on the board, sorry.
You can't read the stuff on the board, and you're telling me this. What? 40 minutes into the third class of the year. Yeah. So.
It's dilates by a factor of 2. In the extra 1.
Dilates by a factor not of 2.
Half.
Half.
Because it's
1 over there.
yeah, okay, yeah.
Okay. Did anyone write it in that order? No. Okay. If you wrote it in that order, it's definitely not right.
If we wrote it in that order there.
If you wrote it in the order that it's currently in, it's not right.
Okay. I didn't know.
Because it's an A, B, C, D.
Right. I just wrote A, B, C, D. That's something that gets done in though.
So I wrote
A, B, D.
I wrote A, D, D, C, is that right?
A, D, D, C is good.
Okay,
Okay. So this. Oh, by the way, you can have A or D first. It doesn't matter. So this is either first or second.
Is that the same with B and C?
This can go first or second. Similar. Yeah. This is either third or fourth. Doesn't matter. That's what. This goes third or fourth. Now, you might be slightly annoyed because I tell you sometimes, like I tell you one way of thinking about it is to do B, D, A, C. Alright? The BDAC thing is helpful for when you're drawing it, but for when you're describing it, you have to go in a certain order. And here's why. Let's run through, what's the BDAC one? So if I did this first, then this second, this last, this third. Okay, so this is if I do B, D, A, C. Right. Oh, actually, let's do it the correct way first. Okay. So we'll go that one before that one, and we'll go that one before that one, just because we've got that one. Okay. So I start with 0, 0. Right? Okay? And they're going to go through this transformation. 1. Dilate by a factor of 4 in the y direction. What happens to this?
The y increases by 4.
Which gives you what?
0, 4.
Still, no, 0, 0.
Oh, wait, yep.
By a factor of 4. So you're multiplying it by 4. So that multiplied by 4. We'll do it in red.
Oh, this is specifically the center point.
Okay? Next move. 2. This. Dilate by a factor of a half in the x direction. What happens?
0, 0.
Still 0, 0. Okay? If I flip that order, is anything going to change?
No.
No. Even if I had numbers in this, would it change?
No.
No, right? Because they're two separate. One's on the x, one's on the y.